Good morning. So this is the last of the general sessions, so it's great that we've got a good turnout. My name's John Poe from the University of Auckland.
Good morning, everyone. I hope you enjoyed morning tea. I am aware that you have a keynote coming up 5 minutes after the session, so we will try and get you out a few minutes early. So if I'm dawdling or being a little bit too slow, feel free to hurry me along. Hopefully we will also have time for a few questions at the end. My name's Daniel Parsons. I'm a cloud architect for a company in New Zealand called Revera. We do cloud infrastructure and cloud services and are part of the Spark group. Just on a personal note, today is actually my 7th anniversary with the company, so it's actually been a fairly long association. Anyway, enough about me. Tertiary communities are changing. Now, I went to university in the 1990s, and if you had taken a proctor from just about any university in history and dumped them at my university, which was Canterbury, in the 1990s, that proctor pretty much would have recognized everything that was going on, right? The systems, the processes, the way students flowed through the university would have all been very, very familiar. You take that same person and you put them into a university today, and they would probably have culture shock, right? The way learning is going is changing, and the way our universities and our other tertiary institutions having to adapt to that means that everything we are doing on a day-to-day basis, simple process workflows, even how we do enrollments and manage data, has to change. I'm not going to talk about everything that's happening through universities. I mean, this is an entire conference about that, and you would have had plenty of sessions on all those sorts of changes. But the two things I do kind of want to draw that are relevant to talking about how data changes amongst the universities are that what we see is that tertiary institutions are becoming increasingly distributed, and they are becoming increasingly online, right? And both of these things have pretty profound implications for how students and researchers and the staff of an institution actually interact with each other and with the institution itself. So with those changes, there are lots of challenges. And a lot of these challenges are around the students who want to be online and on demand and in real time and have access to this stuff, right? When I went to university, if you wanted a particular book from a reference section, you stuck your name on a list. They told you in a couple of weeks when that book had come back, and you could go in and pick it up and have it for a week and then take it. Students don't want to do that anymore. They want to be able to go online and get that information that they need tonight for the paper that's due tomorrow. And people and resources in these institutions are increasingly being shared. So any given individual may actually have ties to more than one tertiary institution. You may teach at one place. You may have interests in a research organization that you deal with as well. You may be doing teaching at even a third institution. And the organization that you work for may have multiple campuses, multiple sites, even in different countries. The institutions themselves need to be much more flexible and responsive and have processes that support people to be on demand and in real time. And the data that needs to make all this happen can be distributed across a whole bunch of platforms, right? The websites of the universities, the enrollment systems in the universities, the resource management systems of universities, and even stored inside individual lecturers' notepads. So we need to bring all of that together and to make some sort of sense about it. And so the buzzword that everyone uses is data analytics for that. And data analytics is about being able to pull multiple sources of data, disparate data together, and actually make sense of them. And data is one of the single most underutilized resources in our institutions today, right? Everyone knows about the buildings and the parking and all of those great things, and the human capital, which is a disgusting term that came out of the 80s. But no one actually considers, or very few people consider data to actually be a resource that can be used to get real, genuine value out of it. So, what do we mean when we talk about data analytics? So, I mean, from days gone by in deep, dark history, we had data. And ever since we've had data, we have processed data and we've turned it into information. Data analytics is a slightly technical term that means doing this in a slightly different way to how we have before. And I kind of want to just talk through what some of those differences are to understand why this is actually a change in the way we do things rather than just the things we used to do in Excel spreadsheets. So the data itself comes from a whole bunch of different places. And previously, when you had data systems, you built a piece of software or some kind of workflow system. It collected the data that it needed to process. It processed that data. It gave you some results, and then typically it threw the data away because it was done with it. You didn't need to keep it anymore. When you're talking about data analytics, what you're actually doing is you're taking data from operational systems, from your CRM and ERP systems if you're a business. You're taking data from your enrollment systems if you're a university, and you're bringing that all together and processing it in new and interesting ways. You're taking data from devices in the Internet of Things, which is a fancy way of saying you've put sensors out into the world and they're reporting on what's going on, right? And so not only are you taking traditional data, which might be here is a student, here is a list of books they've taken out of the library, but you're also doing a lot with time series data, which is at this point in time, on this sensor, we had a reading of this value, right? Now, as a single data point, that's almost completely useless. And the only way you get real value out of it, if you say, what happened to that sensor over time? Moreover, what happened to the sensor that's, a kilometre away or half a kilometre away? What happened to the grid of sensors that I put in this university over time? That's when you get real value out of it. So to make sense of all of that, you kind of need to bring this data together. And in days gone by, people had a concept of a thing called a data warehouse. And this came out of business intelligence, which was a big way of data processing probably in the last decade. And the thing about a data warehouse was you took a whole lot of structured data out of usually a single system, and you put it into a place and you did trend analysis over it. But it was all structured data. It all correlated already, right? If you have a transaction record from your sales system back in 2004, it's basically the same format as a transaction record from your sales system in 2017. And you can compare them straight away. The thing about analytics is that you need to be able to pull data from all over the place that is in different formats and kind of pull it together. So they have a new buzzword. It's not data warehouse anymore. They call it a data lake. And basically what that is you just pour all your data into a big pool and give it a stir. The way that works now is not you have a big database which you put all your archived data in. You actually have to have disparate systems with APIs that talk to each other. And those APIs are actually the key to data analytics, right? Being able to get one system to be able to talk to and understand the data from another system and then correlate it together, or have a third system be able to reach out and grab data from those two and bring it in a new and interesting way, that's the difference. We're not just talking about extending the capabilities of a single system, we're talking about creating new systems which reach out and touch data from others. And in order to make sense of all of that, this data is then filtered. And it's filtered in a context that's drawn from a whole bunch of other data. That's what creates information. And more importantly, because you're able to pull this data out all the time, you can do this in near real time. So processes that tended to be done on paper tended to be done once a month, once a year, once a decade. Whereas data analytics allows an organization to actually look at what's going on right now and respond to it right now. And that's also a huge change to how we've been doing things in the past. But the key about data analytics, and it's on the bottom of that slide there, is it's all about correlation. So you correlate various disparate data sources together, and out of that comes useful trending and analysis. I'll give you an example. You may recognize these two people. This is, in fact, Frank and Claire Underwood. And they're characters in a TV show called House of Cards. Now, Netflix was being created, and they decided that they wanted to make their own content. So what they did is they thought, we're going to make a TV show. What TV show are we going to make? And at the time, they were building a recommendation engine so that when you logged into your Netflix account, it would have a look at what you'd watched in the past and have a look at what other people who'd watched those programs also watched, and then tell you, hey, maybe you might want to watch this one or that one. And they would started doing some analysis on this data. And what they discovered, to their surprise, was that there was this tiny little obscure mini-series that screened in the UK in the 1980s called House of Cards. And there were a whole bunch of people who had put this on their favourites list and their watch list and their watch again list and who had watched it more than once. And they wondered about this, and they did some analysis. And what they discovered was that a lot of these people also liked particular films starring Kevin Spacey, The Usual Suspects being amongst them. What they also discovered is that these people were much more likely than average to have also watched all of The West Wing, sometimes more than once. And what they discovered is that the people who liked this obscure, tiny little mini-series from the UK also liked David Fincher films. Now, you might remember him from such hits as Fight Club or Seven. So what did Netflix do? They hired David Fincher to make a TV series in the style of The West Wing, starring Kevin Spacey, called House of Cards. And rather than the usual way of making a TV show where they make a pilot and then they broadcast it and they see if it's any good and gets a good response, and then maybe they greenlight a series, they funded 2 seasons of that upfront before they'd even started. Because their data analysis showed they had a core group of people who were going to be absolutely passionate about the show, and now it is one of the key properties of Netflix globally. Globally. So data analysis actually can provide you with actionable information, right? It can actually make predictions that allow you to change what you're doing and how you're doing it. And I did want to take a couple of minutes maybe to talk a little bit about why I think this is important. Because 2 of the big words that are going around a lot at the moment are transformation and disruption, particularly digital disruption. Right? And if you look at the music and movie industry in the sort of 2000s, companies like Napster came through and completely disrupted the business model of how that works. And that's still being felt today. If you look at transportation, companies like Uber are starting to disrupt taxis now, but wider in the transport market sort of as time goes on. And companies like Airbnb are starting to disrupt how we book our hotel stays. Right? This kind of disruption is also happening in education. And people are consuming the education product in a different way. People are consuming the research product in a different way. People are making different uses of research data and making a much wider use of research data than they ever have before. And where you have disruption, the response is transformation. And the one thing that almost everyone forgets about transformation is that transformation means you actually have to act differently, right? You can't take the same business process you had last year and just sort of put some lipstick on the pig and do it all over again and say we transformed because we now do exactly the same thing, it's just on an app, right? Digital transformation means actually changing those processes, how they work, their inputs and their outputs. And data analytics is one of the key ways where you can get better inputs, you can get better insights, and as a result, you can get better outputs that actually allow you to transform. If you don't know what's going on in your organization, you can't change it. So, I mean, all this talk about data analytics and everything might seem a little bit dry, but it's actually the driving force behind a lot of what the change that the tertiary education sector as a whole needs to engage in. So let's talk about an example. This is an example from Australian University, actually, who had a big campus. They had multiple campuses. And they wanted to plan how to use their rooms effectively and use that nice resource that they had. They did this as an annual exercise. So once a year, they sat down and they looked back over the past year and they went, this is what our students did, and these rooms were too big and those rooms were too small and these are the problems that we had. Okay, we should change that. They came up with a plan. They tried to implement that plan. And, well, as anyone who's ever been on a campus that planned things this way knows, that plan failed. It cost them a great deal of money and a great deal of hassle. So really what they wanted to do was understand where the people were on their campus. They want to be able to report on them in real time, and they want to become a little bit more responsive to if too many people are showing up to a particular class, we need to be able to give it a bigger room. They approached a company called Hitachi Data Systems, who's a partner of Rivera's, and they looked at some technology that Hitachi had around facial recognition. And they realized they had a security camera network around the university, And if they plugged those cameras into a facial recognition system, they could start to determine how many people were around and where they were at any one time on campus. Realizing, of course, that it is absolutely impossible to get students to swipe a card as they walk through a door unless that door is completely locked. That's the next best thing. If you can look at a room and instantly tell how many people are actually in that room, or look down a corridor and tell how many people are walking down that corridor, you know where people are. And you can start to do really intelligent things about how people move through the buildings and all that kind of stuff. It was wildly successful. They were able to be very much more responsive about room planning and booking, and they saved themselves a packet of money. Cool. But that's not the interesting thing about this. The interesting thing about this is that that was the scope they had when they started the project, right? By the time they finished the project, the scope had expanded massively because all of a sudden they realized if they can visualize this data and make use of it, there are lots of other people who want to know about it, right? The building management systems, the parking people, campus retail. One thing they did do was they needed to have a new exam auditing process. And so they simply used facial recognition technology that was already installed in all of the lecture theatres and rooms to make sure that the people who sat in the room were the ones who wrote their names on top of the papers when they handed them in. And they also built an app that interfaced with the university, and one of the features was campus security. Yes? Was the system... It was put in and designed that it could be anonymous, but with the buy-in of the campus, the students and the staff, they did start to keep some identifying information, mostly to tie it back to faculties and individual people. But when the data comes out of the system through the reporting interfaces, it doesn't give lists of names. The technology would allow that, yes. But you need to then have that linked into a database of who those people are. So your student registration database or whoever that is. And in fact, some systems like this with the building management are actually being used in the US around corporate headquarters where people don't need swipe cards anymore. They use biometrics for the system. So when someone walks up to the front door, the camera identifies who that person is. If they're authorized to walk through the door, it unlocks the door. It turns on the lights from there to their office, for example, and turns the heating on in their office if it's at night. So without having to use swipe cards or other identification, the building itself can start to make sense of that. But without going all the way to that level, you can still say there are 10 people in this room, there are 5 people in this room, and that's useful information as well. Yeah, so the campus security app then also had panic button functionality on it, which then, when that ran out, the mobile phone, they could pull the data from the Wi-Fi of where that mobile phone roughly was on campus. They knew within the last few minutes where a certain person who owned that phone had been on campus, and they could alert campus security that there was something they needed to do about that. They weren't the only benefits, though, that came out of this. And in fact, some of the benefits are much less obvious, and to my mind have much greater transformational ability on the university itself. One of the things they did was around pastoral care. So if you're identifying when a particular person comes into a lecture theatre, you can also see that that person turned up to all of their lectures in term 1. You can also then perhaps tell that that person started to not turn up to lectures halfway through term 2 for a particular course. Now, in a traditional university setting, if the class was fairly small, and some of my classes at university we were on first name terms with the people who were giving the classes, if you didn't turn up, it got noticed. But if I have 1,300 students in my course, I'm not going to notice if one of them stops coming. But if we can detect that, and then we have the ability to start intervening. We have the ability to reach out to those students to say, why are you not coming? Have there been changes in your life? Are there changes in the course? Is this course material too difficult? Do we need to provide you with additional support? So the pastoral care aspect of this, being able to say, over time, rather than just where are people right now, but what have these people been doing, and is this different to what they were doing before? Allows us to intervene and make some really good decisions. Looking at study patterns was another thing that they did. So some of the courses are online, some of the courses are in lecture theatres, and they had combinations between the two. And it was being able to then pull those together and understand a program of study and how people were going through it, and again, intervene or suggest alternatives or additional information or things that they also might want to check out, has meant between those two that student retention and completion rates at that university have significantly gone up. And the university itself, like most universities are, is very concerned with its reputation. And the reputation is not only built around how good the university is and what it does, but it's also built around the cool stuff the university has that's going to attract people. And they've come up with this concept of what they call a living laboratory. And the living laboratory concept was, we have permission to use this data in aggregate to study ourselves. And I mean, as anyone who's ever taken a first-year psych paper knows, first-year psych students are the most studied creature on the planet. And so now the living laboratory is actually a draw card for researchers from overseas, for students to come and make use of this data and this technology. So we've gone from a difficult problem, which was how do I figure out how big a room I need for a course, through to I'm now attracting overseas researchers because I have this cool data set that they're able to play with. I'm now intervening in the lives of my students and ensuring that they have a better university experience from start to finish. And that, right there, is the power of data analytics. We have taken disparate data from a number of sources. We've put it together, and we're able to do things with it that far exceed the original scope of, I need to make sure there are enough chairs in the room. Cool. Which was actually pretty much what I just said there. So, you know, there's operational data. How many people have come? You can take a baseline of analytics and say, right now, where are these people on campus? Or you can then trend that over time, make correlations with our data, and get into this contextual information. And it's the contextual information that actually has the real power to transform the way people do things. If I want to put together business cases on how traffic control or flow control with people moving through a campus is going to look like, if I can get actual real data on if I move this path there, it has this effect, and I can get that data in a week or two, then all of a sudden I'm able to put together we know this will work, this is a worthwhile investment, rather than, I guess if we do this in a year, it might work, which is how so many institutions are currently operating. So, for our perspective, for those who don't know, Revera is a cloud services provider, and we provide the infrastructure that does this. Now, cloud computing really has a number of great benefits. The big one here is that it's on demand, and so you can take a lot of this data, you can take this stuff, you can put it somewhere on low-cost storage, and then on demand, move it to something that's fast and process it in new ways, which means if people have new ideas, they can do new cool stuff. Public, private, and private-ish. So the public clouds, everyone knows, Azure and AWS. The private ones, well, you can build one yourselves, and most campuses have some sort of private cloud functionality on them. Private-ish is the research networks. And they're really, really important, particularly in an educational context, because they allow you to collaborate with institutions without having to have the usual bun fight over who capitalizes the resources. And the private-ish stuff, so in New Zealand, of course, that's REANZ, and Revera is, of course, on the REANZ network. And we're able to then make services available on demand for people to do this kind of cool stuff without having to capitalize stuff in-house, which makes proof of concept really, really easy. The other thing that makes really, really easy is software as a service platform options. Now, most universities have a business unit who is responsible for commercializing some of their research. And you need a place to put that and cool stuff to do. the cloud certainly provides those opportunities in a very easy way. So that's pretty much really what I wanted to say, is that analytics is actually a pretty foundational technology for transformation. It is a new way of looking at data. Data analytics is getting easier, it's getting cheaper. The platforms out there are getting better. Curious, for example, have just launched their scalable data analytics platform in New Zealand. Bringing data together in new ways lets us do cool stuff, and using the cloud makes it even better. And I think we might have just 2 minutes. One question.